Alright, these are the compound inequality notes. Steps to solving a compound inequality. There's two possibilities. The first possibility is like this example here. Okay, it says 2x plus 3 is greater than 2 and 5x is less than 10. So the first possibility is when you have an and. Okay, you must solve each part of the inequality, so you are going to solve 2x plus 3 is greater than 2 separately, and then you're going to solve 5x is less than 10 separately, so you're going to solve both of these inequality problems. And then on the graph of the solution of the conjunction is the intersection of the two inequalities. Both inequalities, again, both inequalities must be met. In other words, the solution is wherever the two inequalities overlap on the graph. If the solution does not overlap, then there is no solution. So for example, alright, if I wanted to graph x is greater than 2 and x is less than 5, just looking at the graph, okay, I would need to draw a number line. Okay, for x is greater than 2, I'd have an open circle above the 2, and greater than, the bigger numbers go this way. Okay, and then x is less than 5, I would have an open circle above the 5, and less than, the less than numbers go this way. Okay, so the answer to this solution is this chunk in the middle here, that it overlaps. Okay, so my answer would be all the numbers between 2 and 5. Okay, 2 would not be an answer and 5 would not be an answer, but all numbers between 2 and 5. Okay, all the numbers in between. Okay, so this is called interval notation over here. So if you use open circles, you use parentheses for your interval notation. If you used closed circles, then you would use brackets. Okay, and you'll see that as we go. Okay, but the answer for this graph is just where they overlap between 2 and 5. The other possibility would be an or. So like 3x is less than or equal to 5, or negative 2x plus 1 is greater than or equal to 0. So and graphs overlap. Both things have to be true. The graph of the solution of a disjunction is the union of the two inequalities. Only one of these conditions of the inequality must be met. So the 3x is less than or equal to 5 could be true, or the negative 2x plus 1 is greater than or equal to 0 can be true. They don't both have to be true. Okay? So in other words, the solution will include each of the graphed lines. The lines can go in different directions or opposite each other. Okay, or they can be overlapping. If the inequalities do overlap, the solution would be all real numbers. Okay, so for example, just looking at a graph, if I wanted to graph x is less than or equal to 5, or x is greater than or equal to 8 on my number line, okay, for the x is less than or equal to 5, I'd have a closed circle above the 5, and less than is to the left. And then for x is greater than or equal to 8, greater than or equal to would have a closed circle, and greater than numbers are this way. Okay, so I would be allowed to use either one of these. Okay, so the answers So the answers would all be all the numbers that I have shaded in here, from 5 and smaller and 8 or bigger. The only numbers that are not answers are actually this chunk in the middle. These are not answers. Okay, everything else is. Okay, so if I wanted to write this in interval notation, okay, since they had closed circles, okay, I would use brackets for closed circles. So all the numbers from negative infinity to 5, close bracket, would be an answer, and so I'd use a U for union, like we used up here, and all the numbers from 8 to infinity would be my other set of answers. Okay? So forever and ever and ever, including 5 and including 8. Oops. All right. So if I end up with something, for example, like x is greater than 4 or x is less than 5, when I graph this on a number line, I'll have 4 and 5. Okay. For 4, I would have an open circle, and this inequality is pointing to the right, so I'll point this to the right. For 5, this inequality is pointing to the left, so I'll have an open circle pointing to the left. These overlap. They're going in opposite directions, and they are an OR, but because everything is being touched, this is all real numbers. Okay? Just as a side note. So sometimes that'll happen. If you have an OR and they do go in opposite directions but they end up overlapping like this, then it'll be all real numbers. Alright, there's an important thing about the ands. Okay, with an and statement it can be written in two different ways. So it can be written with the word and, like in number 2 here. Okay, or it can be written like number 1. 1 is greater than x, which is greater than 3. Okay, these two statements, number 1 and number 2, are exactly the same. Okay, so 1 is greater than x, and x is greater than 3. That's the same thing. Okay, if written the first way, you can split the combined inequality into two separate inequalities, such as the case in number 2. And you do need to do that when you solve. So you would need to break that first statement into two separate statements and then solve in order to, if this was like not already solved for you. Alright, so for example, this is what I'm talking about. This is an and statement. Okay, and I know that because it's all run together like this. So I need to break this apart into 8 is less than m plus 6. And I need to break it apart into m plus 6 is less than 14. When I do that, then I solve each inequality separately, but then graph them on the same number line. So over here in red, I would subtract 6 and get 2 is less than m. And then in blue, I would also subtract 6. But in this case, I would get m is less than 8. And I would graph this on the same number line. Okay, so I know I need to go at least from 2 to 8. Okay, in red over here, when I graph this, our trick to graphing, our shortcut, is to always have your variable on the left. So I'm going to switch the order. When I switch the order, I'm going to flip that inequality symbol. So I'm going to have an open circle above the 2, but Now that this inequality symbol says m is greater than 2, the greater than numbers go to the right. Also, this looks like an arrow pointing to the right, so I'm going to draw this arrow pointing to the right. Alright, m is less than 8. I'm going to have an open circle above the 8. Less than goes to the left. Also, my inequality is pointing to the left, so I'm going to draw my arrow on my graph pointing to the left. So the answer here is just this middle chunk, okay, in between 2 and 8. So when I write that in interval form, I'll have an open circle, a parenthesis because I have an open circle, 2, and then 8, and a parenthesis because I have an open circle. If I had a closed circle, I would use a bracket. Example 2, this is an OR statement. Okay, so I'm going to solve these separately. X minus 1 is greater than 2. Then I'll solve x plus 3 is less than negative 1. So in red over here, I'm going to add 1 to both sides. X will be greater than 3. Then I'll come over here to blue and I'll subtract the 3 from both sides. And x will be less than negative 4. Alright, so now I'm going to graph these on a number line. I need to go all the way from negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Need to go at least from negative 4 to 3 because those are the numbers that I solved. So for 3, I have an open circle. This inequality symbol is pointing to the right, so I'm going to point this arrow to the right. Also, this says x is greater than 3. The greater than numbers are to the right. Then in blue I have x is less than negative 4, so I have an open circle. Less than goes to the left. Also, this looks like an arrow pointing to the left, so I'm going to point this arrow to the left. So my answer is all the numbers smaller than negative 4 or all the numbers bigger than 3. The only thing that's not an answer is this middle chunk. These are not answers, but anything in blue can be an answer, smaller than 4, negative 4, and anything bigger than 3 can be an answer. So to write this in interval notation, okay, since I have open circles, I'm going to use parentheses. Okay, so my numbers can be smaller than negative 4, so that'd be negative infinity to negative 4, parenthesis because it's an open circle, or, and that's the math symbol for or, I can go from 3 to forever, which is infinity. Okay.